On July 18th, a team of researchers at a remote station in Antarctica watched their instruments record the coldest air temperature measured anywhere on planet Earth in 14 years, in the pitch black of a polar night that had already lasted for months. On that exact same calendar day, on the opposite side of the same hemisphere, a city in northern Argentina reportedly went through a night so warm that residents couldn't cool their homes at all, in the middle of what should have been the coldest season of their year. 2 records on 2 different continents on the same 24 hours. One of them is fully confirmed by the monitoring network itself. The other is still working its way through official verification, and we're going to be straight with you about exactly which is which. What connects them isn't coincidence. It's a single piece of atmospheric machinery spinning above Antarctica right now, and understanding it tells you something genuinely important about how extreme weather actually works. Today, we're breaking down exactly what happened, what's confirmed, and what isn't yet, and why a record cold reading doesn't mean what a lot of people online are already claiming it means. No guessing, no dramatizing, just the facts, the science, and what it actually means. Before we get into it, I want to ask you something a little different this time. Have you noticed extreme weather swinging harder in both directions where you live? Brutal heat one week, unusual cold the next? Tell me what you've noticed in the comments. If you want to be the first to know every time the data on something like this comes in, subscribe. It's completely free and it genuinely helps this channel keep going. Let's go for 5,000 likes on this one so the algorithm shows it to more people who are tired of oversimplified takes on both sides of this conversation. Thank you. Now, let's get into it. On July 18th, a thermometer at Concordia Station, a joint French and Italian research base sitting more than 10,000 feet up on the East Antarctic Plateau, recorded a temperature of minus 84.1 degrees Celsius, minus 119.4 degrees Fahrenheit. That is the lowest air temperature measured anywhere on the surface of this planet since 2012, and it came within roughly half a degree of Concordia's own all-time station record. Concordia is one of only 3 inland Antarctic stations occupied year-round, which means there were people there, in the middle of a 4-month polar night, watching the instruments record this in real time. It's worth being precise about what kind of record this actually is, because there's a confusing set of numbers circulating online. Satellite instruments have detected even lower values on the East Antarctic Plateau, figures in the range of minus 93 to minus 98 degrees Celsius reported from orbit. Those are remote-sensed skin temperatures, the temperature of the snow surface itself, not the air above it, and they're not what official record books track. Concordia's minus 84.1 is a conventional air temperature reading, taken the standard way, at a staffed station, which is exactly what makes it comparable to the historical record. On that same July 18th, the city of Salta in northwestern Argentina reportedly recorded the hottest night in its instrumental history, an overnight low that never dropped below 26 degrees Celsius, nearly 79 degrees Fahrenheit, as an overnight minimum in the middle of winter. The climatological normal for that date in Salta sits around 3 degrees Celsius, which would put the reported anomaly at roughly 23 degrees above average. Now, I want to be upfront about something here, because being straight with you matters more than a clean narrative. The specific Salta figure reached wider circulation through a chart built on official Argentine National Weather Service data, but the specific claim of a 101-year record has not yet been confirmed through an official agency bulletin. The underlying data source is legitimate, but this exact record claim should be treated as reported rather than certified at this point. If a formal confirmation or correction comes through, we'll update you on it. I'm including it here because the broader pattern it points to, record overnight warmth across parts of subtropical South America in mid to late July, is well supported by the same atmospheric mechanism we're about to explain, even if this one specific number needs an asterisk next to it for now. So here's the mechanism connecting these 2 events, and it's genuinely more straightforward than it sounds. Deep in the stratosphere above Antarctica sits a structure called the polar vortex, essentially a ring of extremely fast westerly winds encircling the continent, sealing off the air trapped underneath from the rest of the planet. When that ring holds tight, the air beneath it is completely cut off. There's no sunlight during polar night, almost no water vapor because the air is thin and dry, and no mixing with warmer air from lower latitudes because the wind barrier won't let it through. The trapped air radiates its heat upward into space continuously and gets nothing back, so the temperature keeps falling toward the coldest value the Earth's surface is physically capable of producing. That's exactly what happened at Concordia. When the vortex weakens or breaks down entirely, the whole system reverses. Warm, moist air gets pulled poleward, cloud cover increases, and the coldest place on Earth can suddenly run dramatically above its own normal range. Same structure, 2 completely opposite possible outcomes, depending entirely on whether that ring of wind stays intact. In June and July of this year, that ring wasn't just intact, it was unusually strong. There's a specific index that tracks this, called the Antarctic Oscillation, closely related to what's also called the Southern Annular Mode, and it surged to a value of plus 5.00 in late June. For context, a strongly positive reading on this index is the signature of a vortex that's not just present, but unusually tight, fast, and well organized, and forecast guidance had it holding at +2 or stronger through much of early July. The effect on the continent was enormous, with ensemble model guidance through that period showing most of Antarctica, not just one region, running more than 20 degrees Celsius colder than normal, a continental scale cold anomaly. And this was happening at almost the exact same time the Northern Hemisphere was experiencing one of its most heat record-dense summers on record, with over 100 countries reporting temperature records so far this year. Here's where it gets genuinely interesting, because the vortex doesn't just have a strength, it has a position, and that position matters downstream. This year, its core sat near and west of the Amundsen Sea, a location that historically induces a specific atmospheric trough off the central east coast of South America during the austral winter. That trough helps steer the broader wave pattern across the southern half of the continent, meaning the temperature pattern over Argentina and its neighbors is being shaped in part by the exact position of a wind structure sitting over Antarctica, thousands of miles away. To be clear about the mechanism here, because this is the part people most often misunderstand, nobody's claiming cold air physically traveled from Antarctica to Argentina and somehow arrived warm. That's not how this works. What actually travels is the shape of the atmosphere itself. A vortex anchored in a particular position bends the jet stream into a specific arrangement of ridges and troughs downstream, and that arrangement determines which air masses end up parked over which countries. Shift that pattern by a few hundred kilometers, or flip it to the opposite phase, and the same region can go from importing polar air to importing warm air out of the continental interior, sometimes within the span of just a few weeks. Now let's directly address the claim already circulating online, because it needs a clear, direct answer rather than being left hanging. The claim is that a record cold reading somehow disproves the idea that the planet is warming overall. Here's the actual arithmetic. The coldest temperature ever reliably recorded on Earth remains minus 89.2 degrees Celsius, set at Vostok Station in Antarctica on July 21st, 1983. This year's Concordia reading of minus 84.1 is over 5 degrees warmer than that more than 4-decade-old benchmark. A cold record that falls more than 5 degrees short of a record set 43 years ago is not evidence of a cooling planet, it's evidence of natural variability happening on top of a warming baseline. And coldest since 2012 is a 14-year statement about conditions at one specific station during polar night, not a global statement about anything. In the same year this reading occurred, more than 100 countries set heat records. The world's oceans recorded their hottest June ever measured at an average of 20.98 degrees Celsius, and a European heat wave in late June was associated with more than 10,000 excess deaths. There is one legitimate point buried in the broader complaint, though, and it's worth acknowledging honestly. Cold records genuinely do still happen in a warming world, and any coverage that implies otherwise, or that only ever reports one direction of extreme, is simply bad science communication. That frustration people feel is fair. The conclusion some draw from it, that this disproves broader warming, is not. We don't have to speculate about what happens when this same vortex mechanism breaks down instead of holding tight, because it already happened 24 months ago, and there's now a peer-reviewed study on exactly what followed. In July and August of 2024, East Antarctica experienced what researchers describe as the most intense winter heat wave in the 46-year satellite era. Across a region called Dronning Maudland, average surface air temperatures ran more than 9 degrees Celsius above the climatological mean for 17 consecutive days. At 2 individual research stations, temperature anomalies peaked at over 30 degrees Celsius above normal on the very same day, in the middle of the Antarctic winter. The estimated return period for an event of that magnitude was roughly 1 in 135 years. The trigger, consistent with the mechanism we just described, was the earliest sudden stratospheric warming event ever recorded in the southern hemisphere since satellite monitoring began in 1979, which left the polar vortex weakened and displaced. The resulting paper, published in NPJ Climate and Atmospheric Science this past April, found that large-scale atmospheric circulation alone accounted for roughly 47% of the observed surface warming during that event, with enhanced moisture transport, likely aided by a series of atmospheric rivers, raising humidity and cloud cover and strengthening the downward flow of heat radiation back toward the surface. Critically, The researchers also estimated that human-caused warming intensified that specific event by approximately 0.7 degrees Celsius, and more than doubled the likelihood of that class of winter heat wave occurring in today's climate compared to a world without human influence. Their own framing is worth sitting with. What would have been roughly a once-in-several-centuries event under natural conditions alone has effectively become a once-in-a-century event today. Looking forward, the same research estimates the likelihood of similar events could rise to roughly 6 times more likely under moderate emission scenarios and up to 26 times more likely under high emission scenarios by the year 2100. There's one more detail from that same winter worth including, because it didn't get nearly the coverage the more dramatic plateau heat wave did. On June 6th of this year, Esperanza Base, on the northern tip of the Antarctic Peninsula, recorded a winter record of 15.4 degrees Celsius, and daily maximum temperatures across that region stayed above freezing for nearly 3 consecutive weeks in the middle of the Antarctic winter. That resulted in genuine surface melting at the base of nearby glaciers, exposing bare ground in a season when the surface is supposed to be gaining mass, not losing it. This distinction matters enormously. A vortex breakdown centered over the high, dry interior plateau, even one producing a spectacular 30-degree anomaly, generally takes temperatures from something like minus 60 to something like minus 30, which is a dramatic number on a chart but doesn't actually melt anything. A vortex breakdown, positioned instead over the coastal ice, the ice that's actually in contact with the ocean and helps hold back what sits behind it, can cross the melting point entirely and stay there for weeks. It's also worth explaining why a record overnight low actually carries more scientific weight than a record daytime high would, because this isn't obvious, and it's part of why the Salta figure, if eventually confirmed, would matter more than its raw number suggests. Daytime maximum temperatures are inherently noisy. A brief break in cloud cover, a shift in wind direction, a dry air mass sliding briefly over a valley, and a single station can spike for an afternoon without reflecting anything particularly unusual about the broader atmosphere. Overnight minimum temperatures behave very differently. To keep an entire city from cooling off through the night, you need the whole depth of the air mass sitting above it to stay warm, and you typically need enough humidity or cloud cover to prevent the surface from radiating its heat away into a clear night sky. A record warm night is fundamentally a statement about the state of the atmosphere across an entire region, not about one unusually hot moment at one thermometer. That's precisely why, if this specific claim does get formally confirmed, it would represent something considerably more significant than an isolated weather fluke. It's also worth quickly closing off 2 related claims that tend to circulate alongside a story like this one, because they deserve direct, honest answers, rather than being left to linger. The first is the suggestion that meteorological agencies somehow suppress or hide cold weather data. The Concordia reading came directly from the monitoring network itself and was publicly reported within roughly a day of being recorded, which is the opposite of suppression. The second is the idea that an event at this scale could somehow be artificially engineered. The Antarctic polar vortex is a hemispheric scale circulation feature driven by the temperature gradient between the equator and the pole, and by planetary wave activity originating thousands of kilometers away over tropical oceans. Nothing humans have built operates at that scale, or anywhere remotely close to it, and on the question that inevitably comes up around any extreme temperature story. Solar activity during this period was moderate and declining, with a sunspot number in the mid-90s and quiet geomagnetic conditions on the exact days these records were being set. There simply isn't a mechanism by which solar activity produces a +5 Antarctic oscillation reading and a record warm night in South America on the same afternoon. One more piece of context worth including. On the state of Antarctic sea ice more broadly, because an honest video should include the parts of the picture that don't fit neatly into either an alarming or a reassuring narrative. Antarctic sea ice reached its annual minimum this year in late February at 2.58 million square kilometers, the 16th lowest total in the 48-year satellite record, and actually a partial recovery after 4 consecutive severe low ice years, though still sitting well below the long-term average. Growth through the following months has again been tracking on the low side. That's a genuinely mixed picture, and treating this year's numbers as proof of an imminent sweeping collapse would be going meaningfully beyond what the data actually supports right now. So here's where that leaves us. The honest version of this story isn't simply that Antarctica is warming and therefore records keep falling in one direction, that framing misses what actually happened this year. The more accurate, and frankly more unsettling version, is that Antarctica's variability itself is becoming the real story. The likelihood of these dramatic circulation swings has already roughly doubled due to human influence on the climate system, even though there's no clear evidence yet that the swings themselves are becoming more frequent. What's changed is the background they're swinging against. So when an extreme event does occur, whether it's an extreme cold snap or a record-breaking winter heat wave, it now lands further from normal than it used to. The Antarctic Oscillation Index remains the single most useful thing to watch going forward, published continuously, telling us in near real time whether that polar vortex is locking tight again or beginning to weaken. We'll keep tracking this closely and bring you an update the moment the pattern meaningfully shifts, or if that SALTA record receives official confirmation one way or the other. If this kind of grounded, fact-first coverage that pushes back on oversimplified narratives from every direction is something you want more of, subscribing genuinely helps this channel keep making it. Let's try to hit 5,000 likes on this one together. Thank you so much for watching this. Stay curious, stay informed, and I will see you in the next one.